All right, for this enrichment lesson, we are going to be looking at taking solving equations to fraction equations. So still going to be looking at the same solving process. It's just a little bit trickier because we're involving fractions here. All right, so number one, I'm drawing my line down the equal sign. I'm highlighting the variable. First thing I'm doing is I'm identifying the operation that's in the equation is addition, which means the opposite operation, the inverse operation to solve, is subtraction. When we have subtracting of fractions, we have to decide, do we need improper fractions or common denominators? Whenever we are adding or subtracting, we need common denominators. So what I'm actually going to do before I even do the solving process is I am going to rewrite this equation with common denominators. So if I look at these, denominator of 15 and 15, oh, they're already the same. So I'm actually just rewriting it as is. Now I'm going to go through the solving process. We always want to eliminate on the side with the variable. So if you want to highlight it again, our variable's still on the left side. We were adding 7/15, so the opposite is to subtract 7/15 from both sides. On the side with the variable, it should cancel out so that we're left with the variable alone, x. And then on the other side, we're going to actually subtract. We subtract our numerators. 11 minus 7 is 4/15. All right, number two. Again, same process. Drawing our line down the equal sign. Highlighting my variable. Looking at the operation on the side with the variable. I see addition, which tells me the opposite. My solving operation is subtraction. When I have addition and subtraction, I need to find common denominators in order to solve that. So first thing I'm going to do before I even start the solving process is I'm going to rewrite my fractions with common denominators. So if I look at my denominators here, 8 and 4, maybe you can look at those off the top of your head and know what the least common multiple is. If not, use your multiplication chart. So in your resource packet, find your multiplication chart, find 4 and 8, and see what's the lowest number they both multiply into, and that is 8. So the least common denominator, least common multiple is 8. Now to rewrite these, 8 times 1 is 8, so we do the same to the top. 7 times 1 is 7. 4 times 2 is 8, which you can use your multiplication chart. 4 goes into 8 twice. So 3 times 2 is 6. Now I can go ahead and solve. Again, I'm looking at my side that has the variable. We are adding 6/8, so the opposite is to subtract. We always subtract whatever's on the side with the variable. On the side with the variable, it should cancel. 6/8 minus 6/8 cancels out to 0. We're left with just x on that side. 7/8 minus 6/8, we subtract the numerator. 7 minus 6 is 1. We can leave it as 1/8 equals x. If you want to flip it around to x equals 1/8, that works too. Number 3. Drawing my line, highlighting my variable. The side with the variable, the operation here is addition. The opposite is to subtract. When we are adding or subtracting, we need common denominators. So I'm going to rewrite right away with those common denominators. 6 and 9. Their least common denominator, their least common multiple. I'm going to use my multiplication chart. 9, 6 doesn't multiply into 9. 18, 6 does multiply into 18. So the lowest number they both multiply into is 18. 6 times 3 is 18. Again, you can use that multiplication chart. 1, 2, 3. 1 times 3 is 3. 9 times 1, 2 is 18. 7 times 2 is 14. Now I can go through my solving process. On the side with the variable, which is the left side, we were adding 4 and 3/18, so we're going to subtract 4 and 3/18 from both sides. On the side with the variable, it should cancel each other out. 4 and 3/18 minus 4 and 3/18 cancels out. We're left with just x. On this side, we first subtract our fraction values. 14/18 minus 3 is 11/18. Then we subtract our whole numbers. 8 minus 4 is 4. Number 4, drawing our line, highlighting our variable. On the side with the variable, we have addition, which tells us the opposite is to subtract. When we add or subtract fractions, we need common denominators. I'm going to rewrite right away. So it's going to be 12 with some fraction equals x plus 5 with some fraction. 15 and 6. I'm going to check my multiplication chart. I always start with the bigger number. Does 6 go into 15? No. Does 6 go into 30? Yes. So the least common multiple is 30. 15 times what is 30? 15 goes into 30 once. Oops, can't see that. Once, twice. So 4 times 2 is 8. 6 goes into 30. 1, 2, 3, 4, 5 times. So we're going to do 1 times 5, which is 5. Now we are solving. Looking at the side with the variable, we are adding 5 and 5/30, so the opposite is to subtract 5 and 5/30 from both sides. Should cancel out on the side with the variable. We're left with that alone. On this side, we subtract our fractions first. 8 minus 5 is 3/30. 12 minus 5 is 7. I'm fine if you keep it as 7 and 3/30, but if you check to simplify, you can use your factor chart. You'll notice that 3, which divides by 1 and 3, 30 also divides by 3. So 3 divided by 3 is 1, 30 divided by 3 is 10. So this works as well. All right, and then the last two. Again, same starting process. Draw your line down the equal sign, highlight our variable. The operation that's in the equation here, we have a number. So even though we see the fraction bar, this can be kind of confusing. We see this fraction bar, so we might think division, but the fraction isn't in the fraction, or sorry, the variable is not in the fraction. What we do see is that this number is written directly next to the variable, which shows us multiplication. The opposite of multiplying is to divide. So as I've said, we said get away from using the fraction bar for division. That holds true in all normal cases except for with fractions, because it can be kind of confusing to have a fraction within a fraction. So I'm actually going to use the division sign, and I'm going to show x was being multiplied by 2/5, so the opposite is to divide by 2/5. It should cancel out on the side with the variable. If we divide the left by 2/5, I'm going to divide the right by 2/5, and I'm writing it out in this order because that's how we do it for fractions. When we are doing dividing of fractions, I need to turn them improper. So we need improper fractions first. 18 as an improper fraction is 18/1. When we divide fractions, we keep it, switch it, flip it. So keep our first number, 18/1, switch it from division to multiplication, flip it from 2 over 5 to 5 over 2. Now we can look at our two diagonals to simplify. Use your factor chart. 5 and 1. The only thing they share is 1. $18 and 2. They share 2. $18 divided by 2 is 9. 1 divided by 1 is 1. 5 divided by 1 is 5. 2 divided by 2 is 1. And then we're going to just multiply across. 9 times 5 is 45. Over 1 times 1 is 1. So you can leave it as 45 over 1, or you'll realize that simplifies to just 45. So either of those is fine. All right, and then the last one here. We are drawing our line down the middle. We are highlighting our variable. Again, it's a little bit confusing because we do see the fraction bar, but this number is written directly next to the variable, so that's showing us multiplication, so the opposite is to divide. When we multiply and divide fractions, we need improper fractions. So I'm actually going to rewrite them right away, just like we did with adding and subtracting. So 3/4 is already as a fraction, so I'm just going to leave it as 3/4 x. 1 and 1/6 we need to make improper. 1 times 6 is 6, plus 1 is 7 over the original denominator of 6. Now, looking at the side with the variable, we're going to start solving. We said we need to divide. With fractions is the only time we're saying it's okay to use the division sign. On the side with the variable, it should cancel out. You're left with just x equals, and then 7/6, we're going to also show that divided by 3/4. When we divide fractions, we already made it improper. Then we are going to keep it, switch it, flip it. Keep it as 7 over 6. Switch it from division to multiplication. Flip it from 3 over 4 to 4 over 3. Now we're going to look at our diagonals. 6 and 4. 7 and 3. So 6 and 4, if we look on here, they both divide by 2. Seven and 3, the only thing they both divide by is 1. 7 divided by 1 is 7. 6 divided by 2 is 3. 4 divided by 2 is 2. 3 divided by 1 is 3. And now we just multiply across. 7 times 2 is 14. 3 times 3 is 9. And you can leave it improper. And that's it.